Hi guys, welcome back to the Art of Server. So today we are getting back to the R410 series part 5. And up until this point, we've been setting up the hardware. We've installed the FreeNAS OS on this machine onto this USB drive here. And if you recall from part 2 of the series, I specifically chose to use this SAS1 controller. And even though this is a SAS1 controller, so long as I'm using SAS drives, everything works fine. I can use 8 terabyte drives or larger than 2 terabyte drives without an issue. And one of the reasons why I chose to go ahead with this old SAS controller is because I wanted to leave this PCI slot here open and available. And the reason for that is, you see, I think this is a great little machine for anybody who's just getting started. And if this is your starter NAS, and at some point, so you can basically start with 4 hard drives, and at some point you might say, hey, I need more storage, but I don't want to necessarily buy another server to have 2 servers or upgrade to a larger server. I just want to add storage. And so if you have this PCI slot available, you can basically add an external HBA card and attach a disk shelf, or often known as a DAS, or direct attached storage, or sometimes also called a JBOD chassis, or just a bunch of disk chassis. And so I'm going to show you how to do that today. I'm going to show you how to build your own JBOD. So down here is the Supermicro 836. This is the machine that I commonly refer to as the Flash, because I use this machine for flashing all the HBA cards that I sell. And today I've gutted this machine, and I'm going to show you how to set this up, not as a server, but as a JBOD chassis. So it'll basically just run hard drives, and we're going to connect this to the R410 and have the R410 basically as a controller head for all these disks down here. So I'm going to show you how to do that. If you want to set up your own, I mean, of course, there are other JBOD chassis out there you can buy that are already kind of set up. Oftentimes, they're quite noisy, though. So I want to show you how to set up your own, because that'll give you some customization choices to lower the noise level and all that other kind of stuff. So anyway, let's get in here, and I'll show you how you can set up your own JBOD chassis. Hi guys, okay, so welcome to the inside of the Supermicro 836. As you see, there is no traditional motherboard in here. I've gutted this system in order to show you guys how to set up a JBOD chassis. So when you're setting up your own JBOD, there's a couple of components, kind of primary components you need to consider. One is, how do you power on the thing, right? So most ATX type of chassis have a some sort of ribbon or wires that go from the power button to the motherboard, and by shorting the power pin to ground, that signals the motherboard to turn on the power. And so in order for that to happen, and so that you can actually power the backplane, to power the hard drives and all that stuff, you need some sort of mechanism to turn on the power. In addition to that, you're going to need cooling, right? Because you've got hard drives that are generating heat, so you need airflow. And you need a way to turn on the fans and regulate the fans. In addition to that, you need storage connectivity, because once you've got the fans going, you've got the proper cooling, you've got the power, you've turned on your hard drives, you need your hard drives to be connected to the main server that's going to be driving them. And so for that, I've got this set up here, and I'll go into each of these components in more detail shortly here, but I just want to give you the general overview. So we have to have power, we have to have cooling, and we have to have storage connectivity. Those are the 3 primary components you need to consider if you're going to build your own JBOD chassis like I have set up here. Okay, so let me just describe to you what I've got here. What I have here, this tiny little board that is kind of the replacement for the motherboard right now, is a Supermicro PT JBOD CB2. And this is basically a JBOD controller board. Supermicro makes a couple different models. There was an older CB1, which I think has more or less the similar features. I don't quite remember the difference between CB1 and CB2, but there is a more advanced one that's called the CB3, so the PT JBOD-CB3. And that one has remote management and all this other fancy stuff. It has better fan control and fan speed regulation capability. You know, that would be very desirable, except that board is normally pretty expensive. I see that it goes for about $150 to $200. And so for that price, you could actually get yourself a, actual motherboard with like a real CPU and everything like that. So I kind of find that not to be very cost effective. And so if you're needing just a very, very basic JBOD, I would normally recommend something like the CB2 or the CB1. And I think these are almost the same. The CB1 and CB2 are almost the same price. I think there's a difference about $2 or something like that. I got this one used from a forum member on Serve the Home, and just to experiment with. And so I have this here, and you can see that it's connected to the power connector from the power supply, or the power distribution board. And so this is how power is run. This board will basically turn on or turn off the power supply, and it does that by this connector here that is connected to the power switch. So instead of the power switch turning on a motherboard, we're basically using this board in replacement of that, and it's going to turn on the power supply. In addition to that, there are two fan headers here, and I have a splitter here because I have 3 fans, and so I have a splitter here that runs these 3 fans. And so you'll see, let's see, yeah, you'll see like that one of these here is not connected because I only have 3 fans. Now if you want to add, there are spaces for 2 more fans here, so if you need a little bit more airflow, you kind of feel like the hard drives are a little bit hotter than you'd like, you can always add more fans and run additional fans from here. Okay, so this covers basically the power and the cooling all in this board here. All right, the last part, as I mentioned earlier, is to run your storage connectivity. So I've got a direct attached backplane here. This is the 836TQ backplane. So let me remove one of these power supplies so you can kind of get or let me remove a couple of them. So this is a direct attached backplane that has individual SATA connectors, as you can see here, for every hard drive slot. And those are aggregated in these cables. So these are forward breakout cables, and they go into this SAS expander card. And this, normally I would use, by the way, this is a new SAS expander card that I'm selling in my store, or soon to be selling in my store. Up until now, you've heard me talk a lot about the IBM 46M0997, and I still sell that, although I'm currently sold out. I'm having a hard time sourcing that at a reasonable price. My suppliers keep raising the prices on me, so I'm starting to look for alternatives. And so I've got this guy here, which is from a Lenovo server, and it basically functions the same way. It doesn't seem to have any of the firmware bugs that the IBM one had. So guys, if you're interested in this expander and you want an alternative to that 46M0997, this is the Lenovo 03X 3834 board, and you should be able to find this in my store. I'll also, if I have this thing listed, I'll have a link in the description of this video for you. So if you're interested in an alternative SAS expander, go ahead and check out that link. Anyway, this is a SAS expander, and I've got the 4 SAS cables coming from that backplane into this machine. So this is kind of a way to aggregate all your storage from the backplane. If you were to basically convert these connections into external connections directly, you would need 4 SAS connections in order to drive all the hard drives in this chassis. And you know, if you needed that kind of direct bandwidth performance, then you know, maybe you'd go ahead and just do that. But a lot of times, since we're expanding storage for more or less like bulk storage, so you're storing media like, you know, large movie files, that kind of stuff, you don't really need the direct connection bandwidth. You just need the ability to have a lot of hard drives connected. And so in that case, it's good to use the expander to kind of aggregate all those connections. And you can see here I've aggregated them into 2 connections that are then connected to this adapter board that converts from an 8087 internal connection to a 8088 external connection. And so I've got these 2 connections, and you can just use one. Like I've mentioned in a lot of my expander board videos, you can drive the SAS expander with just one connection, which will give you 24 gigabits of bandwidth. And this is a SAS2 expander, so it's 6 gigabit times 4. And if you wanted a little bit more bandwidth than that, you can basically connect the second one and get yourself 48 gigabits of bandwidth, of SAS2 bandwidth, basically from this expander to your primary server that's controlling this whole thing. All right, so that's how you would take care of the storage connectivity. And so And one other thing, this SAS expander is powered by a PCI slot, and since I don't have a motherboard in here, I'm using one of those GPU PCI extender type of things that's powered. And I've shown this, I've shown how I've used this to power on the 46M0997 SAS expander. It also works with this expander as well. And so I'm using one of these since I don't have a motherboard with a PCI slot in here, and I've got this connected via a Molex that is run through the power cables over here. And so this is how I'm powering on. So when I hit the power switch, and I'm going to turn this on just to show you guys that this all works. When I hit the power switch and that turns on the ATX power supply, that then turns on the power for this GPU adapter thing, and that turns on the SAS expander. And so that basically powers on all the components that need to be powered on within this chassis. And then as long as I have the primary server connected to this adapter with external 8088 SAS cables, that primary server, the R410, will be able to see this expander and therefore see all the hard drives that are connected to this backplane. Okay, so that's how you set up a JBOD chassis. You basically need a couple of different components. Again, you need something that will basically turn on the power. You need something to manage the cooling for the fans, and you need something to, well, I guess turn on power for any kind of storage devices in here, like the SAS expander. But you need to have the connectivity for the storage to go out the chassis, so that then you can connect that to your primary server that will be driving the storage in this chassis. Now, there are a couple of drawbacks for with this setup. One is that when you power on your primary server that's expecting to see all the hard drives in here, you have to make sure that this thing is powered on before you power on the server, right? And so there's a little bit of coordination that needs to happen there, and that's a little bit hard to automate in this particular setup, because the only way to power on this board here is really for someone to like hit the switch, right? And so it's basically a manual procedure. You have to make sure you power on this chassis before you power on the primary server that's going to be driving the storage. So that's a little bit inconvenient and not so obvious. If somebody else is turning on the machine for you, you have to explain the whole procedure of, hey, make sure you turn this guy on before you turn on your main server, right? And if you accidentally power off this system, then your primary server is going to basically lose a bunch of storage, and that has varying degrees of problems that can cause. So that's one drawback with this setup, and that's one reason why some people will go with a more sophisticated JBOD board, which is that PT JBOD-CB3, because it has a remote management capability. But I'm also going to show you later on today a hack around that. That is much less expensive than that JBOD CB3 board, that will essentially get you kind of the same features. Okay, and then the other thing about, why would anybody want to build a JBOD chassis on their own rather than buying one? And that is a lot of the JBOD chassis out there that are available from Dell or something like that. For example, the MD1200, MD1000, those type of machines, they're very, very affordable, by the way. But one of their main problems, especially for home lab users, is that their fans just run at extremely noisy RPMs. And in this case, I haven't done anything here. So when I turn this on, the fans are going to be relatively loud. I'm going to show you that. But because I am basically wiring the fans myself, I have the option to basically add a resistor here. And so you can basically manually control and slow down the fans to reduce the amount of noise this box is going to generate. Now, of course, you're kind of overriding the default design of what this board is supposed to do. So in that case, you have to be extra careful in terms of the cooling capacity of the system. Once you're in full control of the fan speeds by adding resistors to this, you're also fully responsible to make sure that you have enough cooling to keep your hard drives cool enough. So if you're going to be doing that, you start lowering the RPM of your fans. You need to keep a close eye on the temperatures of your hard drives to make sure that they're not overheating. And if they are, you might have to reduce the amount of reduction that you add to slow down the speeds, and get enough fan RPMs to keep the system cooled to an adequate level. So just remember that. But by building your own, you really do have the flexibility of basically controlling how this whole thing works. So like I said earlier, I'm going to power this machine on just to show you that all the stuff works. So we're going to go ahead and turn this thing on. So you can see that the green LED on this board is on. That means this thing has power. That power button basically triggered the power supply to turn on. I got the fans rolling. It's a little bit loud because there's not a lot of fan control with this board right now. But you can see that the drives are spinning up. I think we missed some of them. Now, one thing to note is that because I have a SAS expander in here, as soon as that SAS expander powers on, it's going to scan all the hard drives. So, by the way, that's one of the advantages of having a SAS expander, is that even before your HBA card powers on and starts scanning your hard drives, the SAS expander will do that for you. And so oftentimes it can kind of speed up boot times, because you don't have to wait for your HBA card to scan all the hard drives. It'll already see all the hard drives are spun up. So anyway, as you can see, I also have a light on this PCI adapter board thing for the GPUs. I don't know why that's red. Maybe that's normal, but I know it's powering on the SAS expander because it's getting warm, and as you saw earlier, all the hard drives were spinning up. You can see that the green LEDs on the backplane are on. That means that the backplane is getting power, and so all the devices here are getting power. So basically that's, you know, a demonstration that this whole setup actually works. I've got the JBOD board basically turning on power, powering on my fans. It's turning on power to my SAS expander, and as you saw, the drives that are in here were getting scanned and spun up, and that's because the SAS expander is working. And so anyway, just wanted to demonstrate that this whole setup here actually powers on and works. And all you really need at this point is to basically connect this to an external HBA card that will basically connect the hard drives to your main server. All right, so I'm going to go ahead and power this off now. So anyway, hope this helps you understand what a Jbot chassis is and how it's built. But I'm going to show you how you can get around instead of using this JBOD controller board, but instead using a regular server motherboard that is usually significantly cheaper than that CB3 board that I was just mentioning earlier. So, all right, let me go set that up, and we'll talk about that in a second here. All right. Welcome back to the Supermicro 836 chassis. As you can see, I've swapped out some components in here, and so let me explain to you what I've got here. I have a Supermicro X9 SPU-F motherboard, and this is one of Supermicro's proprietary format motherboards. And the -F there is kind of part of the secret sauce here, is that the -F indicates that this has a network managed BMC, or otherwise called IPMI. So you can see out here I have a cable connected, the link lights are blinking, and so I'm able to actually connect to this motherboard over the network and remotely turn on the motherboard, turn off the motherboard, and you know, some of the remote management features basically will work. Now you'll notice that this motherboard does not have a processor and has no memory, and so the hack here is that basically I'm using the X9 SPU-F motherboard purely for its BMC functions and the remote management capability that comes with it as well. So by the way, any Supermicro motherboard that has a -F in it basically has an IPMI network interface, so that you can do remote management on the motherboard even when the motherboard is off. Now in this case, this X9 SPU-F motherboard I picked up off eBay for really cheap. It was about $20, and so that's kind of the part of the secret sauce here, is that you want to hunt for motherboards, server grade motherboards that have remote management capability. So in the case of Supermicro, you want to look for the -F. And in this case, you'll see that this motherboard is kind of a quirky format. It's one of Supermicro's proprietary formats that doesn't really fit in the standard case or ATX type of case. And so when resellers or server recyclers receive a bunch of these boards, they're kind of hard to sell at first. They're really only meant to replace motherboards that have died in a server. So someone who already has the full chassis and maybe the motherboard had a problem, they want to replace the motherboard, they might be interested in buying this board to replace that. But otherwise, this motherboard doesn't have a lot of applicability, and so therefore sometimes you can find them for a very, very reasonable price. And like I said, I was able to find this for about $20 a while ago. I'm not saying that you'll be able to find this for $20 right now, because prices on these kind of things do fluctuate, but the type of thing you want to look for is one that has remote management. So in the case of here with the -F, and you want to maybe look around for proprietary formats that are less desirable, and so therefore the prices will be a little bit lower. Okay, so I'm using this motherboard again purely just for its BMC functions. You'll see that I have the power connection connected. I've got the PM bus to the power connected. I've got the ribbon cable that connects to the power switch. So when I hit that power switch, it's going to power on the motherboard. And although it will not function normally because I'm missing the processor and the memory, what I do get out of this is that I will get the fans to power on, and I will get power to the PCI slot. So by the way, this is another bonus of using a motherboard like this. I no longer need an adapter to power on the SAS expander like I did in the previous setup. So so that's kind of an extra added bonus by using a motherboard like this. Now, this PCI slot is not really meant for a normal PCI card. It's meant for a PCI riser. And so the position is a little bit off in this case, so I had to remove the PCI bracket on the SAS expander. As you can see, it's kind of sitting loose, but it's good enough to power the SAS expander, and that's really all I need. And there's not going to be anything connected directly to this, so it's not like the SAS external cables are going to be attached to this, so nothing's really going to be moving this. So long as I close the case, this is going to be just fine. You could also fabricate a bracket to kind of hold this into the PCI slots if you wanted to, but anyway, that should work just fine. So I've got power and the power switch, I've got fans, and I've got power to the SAS expander, and again the SAS connection here where I have the 4 SAS cables coming from the backplane going into the SAS expander, and then coming out of that with 2 SAS cables to the adapter that converts those connections to 8088 connections that we can later connect to the R410 via external SAS cables and an external SAS HBA. So that gives us all the ingredients we need to run a JBOD chassis. And in addition to that, let me also mention that you'll see that the fan headers here, I have several fan headers, so that's another advantage, but I've connected these fan speed reduction resistor cables from Noctua, because I'm going to slow down the fans here just to kind of demonstrate to you that there is some ability to control the fan speed, and that's one of the advantages of building your own JBOD chassis, is that basically you are in control of how things are put together. Now, there are many ways to reduce the noise. I know that's a big concern for a lot of people who are building these things for their home environments. I'm just kind of demonstrating that a very easy way to do this is simply to insert one of these resistors that will lower the RPMs of the fans to reduce the noise. But again, as I mentioned earlier, you do have to be responsible for your own cooling. Make sure that however much you reduce the airflow, that it's still adequate enough to keep everything cool enough for what you're doing. So now I didn't do this early in the previous setup because I knew that I wasn't going to really use that. That was kind of a proof of concept just to show you guys what are the basic principles of setting up a JBOD chassis. I really wanted to show you this setup instead, and the reason is, as I mentioned earlier, this motherboard was $20, and so that little JBOD controller board, the CT JBOD-CB2 board, that was, you can find them for somewhere between $50 to $60. So this is really a fraction of the cost of that. Now, this board will consume a little bit more power just because when you turn it on, the PCH will power on, and even right now when it's powered off and only the BMC is on, it's consuming about 9 watts. And so it's going to consume a little bit more power than that. And so there's that one disadvantage, but on the flip side, I've got all the functionality of that board. I'm able to connect the power switch to the power to turn on the power. I'm able to turn on the fans, and and in this case I actually have the bonus of being able to power the SAS expander without an additional adapter board or anything like that. And I guess most significantly is that I have a network management interface, basically. So this is going to allow me to power the system on remotely. And as I mentioned earlier, in the previous setup, if I were to turn on the server, I have to manually coordinate turning on the JBOD first to make sure this is all spun up and ready to go before I turn on the main server that will then drive all these hard drives in this system. In this case, because I have the ability to network manage this board, I could set up, for example, a program that can power this on remotely from the server and make sure that this is all working before the server tries to import the ZFS pool on the system. So then I don't have to if I set that up, then I don't have to manually remember to turn this on. Basically, the main server will be able to turn this thing on remotely over the network. So that's one of the main advantages of going with a setup like this. And also that the cost is basically a fraction of what the previous setup was in terms of the cost of the board here. And now I mentioned earlier that there was another Supermicro JBOD board, the CT-JBOD-CB3, and that board goes between somewhere like $160 to $200, and that does have remote network management capability like this would have, but again, that is at least 8 times the cost of what I paid for this board. So anyway, this is kind of the hack that I wanted to show you guys. There are, this is not the only motherboard that can be used in this way. There are many other boards out there. This just happened to be one that I picked up for really cheap. Like I said, it was only about $20, and so I thought I could use it for something like this, and that's why I picked it up. And so if you guys are looking for kind of a budget build and you want to set up your own JBOD without spending a lot of money on it, I would say look for something like this. There are many motherboard options out there that will allow you to have remote management capability and give you a PCI slot in case you need it to power a SAS expander like that. So all right, so hopefully that gives you guys kind of another idea of how to set up your own JBOD chassis. But next I want to power this thing on just to show you how much quieter this is compared to the previous setup when I didn't have these fan speed reducers. So let me go ahead and power this on. So you can see that the SAS expander is scanning all the drives. So this row and this row got powered up. Now this row or column actually, I'm looking at it sideways here, but here you can see everything's getting spun up. So at this point, everything is basically ready, and we can have the R410 basically import any ZFS pool that's on those drives right now. So I don't know how it's going to come through in the mic of this recording, but this is definitely a lot quieter than what I had in the previous setup. And so hopefully I'm not, in the previous setup when I powered that thing on, I was kind of yelling in order to hope that what I'm saying gets recorded in a way that you can actually comprehend. But right now I'm just speaking at a normal level, and I'm pretty sure you're going to be able to make sense of what I'm saying because the fans are just not that loud right now. So I don't know if the fan speeds in the current setup is adequate to cool the system, but that's something that if you were building this for actual use, you'd have to kind of observe and make sure that you're getting enough cooling, and if not, you'd have to swap these things out for something that maybe allows the fans to spin a little bit faster. Okay, now one final thing before we get all this closed up and set up the R410 to drive this JBOD chassis is that I want to show you another alternative to this SAS expander. Okay, so what I have in front of me here is a backplane, an expander backplane for this Supermicro 836. This is the BPN-SAS2-836EL1. This is a single expander SAS backplane, and if you're interested in using one of these after I kind of describe this to you. I do have a video on showing you how to swap this out of this 836 with a TQ backplane. So now the TQ backplanes, by the way, these are really affordable. Like if you find an 836 on eBay that has a TQ backplane, it's actually really cheap. And you know, the ones that come with an expander backplane are usually more expensive. So you kind of have to do the math a little bit to see, you know, what price can you get the whole chassis for, how much, you know, are you going to need to pay for this expander, and whether that is a more cost-effective solution versus something like this. But basically, this is a backplane for this chassis that has a built-in expander, and you'll see that there are 3 ports here. 2 of these ports can be used to uplink to your HBA card, and a 3rd port is used for basically downlink to connect to additional SAS expanders, or you can basically run this cable out outside the chassis, like with an adapter like this, so that you can then daisy chain that to another disk shelf if you want, you know, to further expand your storage. So in a case like this, if you were to use this backplane, you already have these 2 cables coming out, and you connect it to an adapter straight to this. You'd bypass this whole SAS expander setup internally, and so it kind of saves you a little bit of, you know, the complication of having to figure out how to power this thing. In our case, now that we're using this X9 SPU-F-F motherboard, we kind of have a PCI slot to take care of that problem. But if you didn't, you'd have to find some alternative way to power on a SAS expander, whereas if you used a built-in SAS expander backplane like this, it already gets power directly from however you're powering this backplane, which in this case are these 4-pin Molex connectors. So anyway, I just wanted to mention that because that would be an alternative way to kind of simplify the setup a little bit. Although oftentimes the chassis that come with a SAS expander already can be quite more expensive, but you know, sometimes you can get a good deal, so it just kind of depends on what you find out there. So if you already have a TQ backplane chassis, you can set it up with a independent, you know, SAS expander like this. If you're just going out there shopping right now, you know, I would say, you know, take a look at chassis that have an expander already built in, and kind of do the math and figure out what works out best for you. Would it be more advantageous just to get one that already has a SAS expander, so you don't have to buy an expander and not worry about having to figure out how to power it, or you know, if you get a really good deal on a really old 836 that has a TQ backplane, you know, then adding an expander, you know, might come out to be a little bit less than buying one that already has an expander in it. Alright guys, so at this point I'm going to close up this system, and we're going to get the Dell R410 ready to drive this Jbot chassis. Alright guys, so we're in the R410 right now. I've already removed the lid. I'm going to be using this LSI external SAS HBA card. This is a 9207-8E. If you're just using hard drives, you could also go with a 9200-8E as well, but I just happen to have this in my lab. This is actually one of the orphans I've adopted. Like I said, I test and examine every card very carefully. This one actually fully works, but this inductor here has some cosmetic damage there, and so I don't usually sell stuff like this. So anyway, this ended up in my lab just for experiments like this. But anyway, this is what I have. This is what I'm going to be using to install in the R410, and then we're going to connect it to that JBOD chassis I just showed you earlier with these 2 SAS cables. So let's go ahead and get that installed. So I'll take out the bracket here, and we'll put the card. In we go. Alright, so I don't need the bracket anymore, and we'll plug in both connections. Alright, so that's pretty much all we need to do, and so this is how I wanted to use, you know, this extra SAS PCI slot and keep that available by using the onboard SAS controller option. So now we've got the 4 hard drives connected within the chassis of the R410 via this SAS controller, and we've got this external HBA driving the 16 drives that are in that Supermicro 836 JBOD setup that we just saw. So all right, I'm going to go ahead and power this on right now, and we'll connect to this via the web interface, and we'll kind of take a look at setting up a pool and stuff like that on that JBOD chassis. So guys, I've got the R410 powered up now with FreeNAS, and this is the web UI. So let's go ahead and log in here. Alright, so we already have one pool here, which is based off of the 4 internal hard drives in the R410. And let's go over here to storage, and we'll look under disks. And so here, the ones that are in data 1 pool, you'll see are the 4 terabyte hard drives. And now I've got an additional 16, so from DA4 all the way down to DA19, so that's 16 additional drives. Now these are 400 gigabyte drives, they're SAS drives. And so if I want to create a new pool out of that JBOD chassis, I can do that. So let's go ahead and just do that right now. So we're going to create new pool. And let's go ahead and add all of these drives. I think that should, that should cover all DA4 through DA19. Let's bring those over. And I probably need to give this a name. So let's call it here, JBOD 1. Okay, and have it under RAID Z3. I don't know. Let's do RAID Z2 instead. Alright, so let's go create, confirm, create pool. Alright. So while we're waiting for that, I also wanted to show you the Ipmi interface on that JBOD chassis. So, so here is the JBOD chassis Ipmi interface. It got an address via DHCP. Of course, you can always statically configure that as well. In my case, it's on 217. So the login here is, let's see, admin, which is the default. Okie dokie. Alright, I won't worry about that. So yeah, so you can see that I'm actually able to remotely connect to that JBOD chassis, and I can power down the machine, power on the machine, reset the machine. Now, I'm not limited to doing that just through the web UI. You can actually send Ipmi commands over the network. And so directly from the R410 server, if you have the Ipmi tools, you can send that command over the network to the JBOD to turn it on or turn it off and do whatever you want with it, basically. Now, obviously not everything here is working, again, because we don't have a processor or memory in there. So if you went, for example, to go look at the sensor readings, they're not going to be present just because the stuff is not there. And I believe it needs a CPU in that motherboard in order for it to register some of these sensor readings and stuff like that. But, you know, again, this is a $20 board. I don't really care if I can't use all of it at this point. I'm using it for what I needed to do, which is just power on the system, the chassis, the backplanes, that SAS expander, and turn on my fans and allow me to remotely connect to it and turn it on and off. So yeah, so a lot of this functionality is not going to work. Now, that said, I can continue using this motherboard as is without a CPU and stuff like that. But, you know, if you are okay with adding a few more watts to your overall system and install like a really low powered CPU in there with a minimal, like say 1 gig of RAM or something like that, you know, you could then enable some of these missing features here. And that might give you some other additional possibilities. I haven't really thought about that, but you know, considering that is an X9 motherboard, it can take an Ivy Bridge processor, and Ivy Bridge has been fairly power efficient. So you can get a very low powered Ivy Bridge Xeon CPU and put it in that motherboard and basically get yourself some additional functionality to maybe control the fans and stuff like that. So, and by the way, the X9 platform, in this particular case, this X9 motherboard, you can control the fan speeds via different fan profiles. And so by adding that CPU to this motherboard, and it's going to cost you a few more watts and running the CPU and RAM, but it would give you some more flexibility to programmatically change the fan speeds with a script or something like that. So so that might give you some additional possibilities there in terms of fan control without having to do kind of a hardware hack of putting in a resistor and stuff like that. So anyway, I don't have a processor like that right now. Otherwise, I'd actually go test that out and show you guys. But I definitely think that's a possibility that might be worthwhile to somebody if you're willing to spend a few more watts on running a CPU in this motherboard. So anyway, I just wanted to show you that that motherboard without the processor and RAM right now can be remotely managed, at least with this minimal functionality like this. So all right, I'll go ahead and log out of that. Let's go back to FreeNAS, and our pool is done. We have a 4.6 terabyte pool of 16 drives, and yeah, so there you have it, guys. Just wanted to show you how you can use this R410 as a starter NAS and then expand it later on by adding a Jbot chassis, and how to build that Jbot chassis all on your own with a lot of cheap component ideas there. So anyway, I hope you enjoyed this video. I hope this has been helpful for anybody who is considering this R410 for future expansion. Now you kind of know how you can expand it. And for anybody who's just interested in building their own Jbot and maybe you weren't too sure about what you needed to do there, I showed you kind of the formal way of doing it with that PT Jbot CB2 board. That would be kind of the formal, normal way to doing a Jbot chassis. But if you wanted to kind of go on a cheaper budget and willing to kind of look at some alternative options, then I've also showed you how to do that with kind of a server motherboard that's not fully functional, or without CPU and memory. You could still be used as a Jbot controller board, basically. So anyway, hope you liked this video. If you liked it, make sure to give me a thumbs up for this video, and if you're new to the channel, be sure to subscribe and hit that notification bell so you'll see new videos from me. And anyway, thank you very much for watching, and have a great day, guys. Bye bye.